Interesting. Yeah, so what excites you guys about QC, QAR? What are the biggest open challenges today? Generally speaking, like the thing that you worry about before you go to bed.
Hopefully not, right?
Yes.
I think that's the point about QC, that you don't worry about it before you go to bed. That's the idea.
And I worry that people don't do it, to be honest.
Yeah. I see your point. I think that's actually the most fundamental obstacle, right? That it's not done, whatever it is. So I think very often we basically say, better do something, even if it's not perfect, but make sure it's done. I think I agree with you on that. Yeah.
It's too hard. People sometimes they just say, oh, we looked at it, but God knows what they looked at, whether they looked at in the right places and whatnot. And reviewers are oftentimes too, what's the word? Kind, if their authors claim we looked at it and end of story, So I'm trying to, I talked to Peter Michael Breakspear about this, if we can have some kind of a requirement at the peer review stage that, when authors say that they QC, well, we have to force the authors to do it in a way. They have to declare that they did QC appropriate for the data and analysis and give detailed steps. But that leads to the question about consensus. What is the accepted way to do QC? It goes to the core aim of this group, as in we don't have that to implement it as like a required step at each, at the peer review of each paper that is being published. So if we can get there, even for the most common use cases, such as fMRI, active and weighted MRI, I think that would be a great progress. We can install that small gate at various popular journals like HPM, Neuroimage, Aperture, and whatnot. I would improve the quality quite a bit. Just having that little step and making people declare something with minimum required parameters, for example, based on COBIDAS,
Sorry, based on?
COBIDAS. COBIDAS is the
COBIDAS,
yeah. They wrote some guidelines on best practices in reporting.
I think it's always the convincing argument isn't the convincing argument always when it makes life easier for people, then they do it. So if you can kind of solve both issues at the same time, it's usually when it works best.
Yeah, unfortunately, the only way to make it easier for them is to give a lot more money and resources to them to make it happen, and that we don't have, right? Because the big data sets, most of the time, good QC is all manual, or at least semi-automated. It still takes weeks and months to do it, and that's the bottleneck. Hello, everyone. A lot of new people came up. Dr. Wald, nice to meet you. And we'll give it a few more minutes. I don't know if Peter is here.
It is true that big data requires manual intervention, but for any data set that you acquire, the amount of time that's already gone into it is vast already. So QC is actually just a little bit more on there as well. I guess if you're using a public data, then the burden becomes on you. But people write a grant, they spend months writing a grant, they spend days planning things, piloting, hours acquiring the data, training the postdocs, postbacks, graduate students who are doing it. And then we're talking about, just minimal QC doesn't take that much on top of it. So it is true. It depends how you want to evaluate the time added cost of it.
Yeah, I mean, yeah. So one of the ideas I have, I've often mentioned it in the group, is to crowdsource the whole process. Like we have open data sets like ADME, ABCD, and others. Oftentimes, we just need to QC it once. Well, that is not being done today because there is a block of do not redistribute clause on these data sets. So whatever I can get from ABCD within my collaboration, I have to keep it there. I can't openly share whatever I derived from it, So we need, if we remove it, and then everybody helps in QCing the data set once, and it's done forever. And it saves a lot of time and effort going forward, and it's not being done. And I think we need to help change it.
Yeah, that's very
I
true.
guess
There are some open data sets, I guess, where that could be started already, and then maybe that would the benefits of those would become apparent, and then even the people just with these other ones would have a way to make that work as well.
Yeah, and also another reason for it that needs to be open is because there is multiple ways to do it. We need to be able to compare that in a way, and I think that is best done if we keep everything open. And most of it is happening in silos in individual papers. There are comparison studies, but not as open as we would like, given the complexity involved in these comparisons. So anyway, I think we should probably get started. So thank you, everyone, especially the panelists and speakers, for kindly taking the time and preparing to join. So given we only have like an hour and a half, I'm thinking maybe we'll just skip the introductions, because I think most of the people know each other here. And I apologize if that is not the right way to do it, but let's probably get going based on maybe with Peter Bandettini, going by last name. I know that 3 people are speaking today, Peter, Robert, and John. So if anyone else is interested in, let me know. I'm thinking roughly about 15 minutes, 10 to 15 minutes, depending on how well they're prepared. And then we open it to open discussion. Usually we do it interactive, but I think for this time, let's just skip through the 3 presentations and keep the questions to the end. Does that work?
Sounds good. Sounds good.
Perfect.
So I just have a pretty short presentation just to give like the highlights of the core facility. And let me just, if I can just share my screen, I'll just do that. All right, can you see that? Can everyone see my screen? Okay.
Yes.
Good. All right.
Yes.
Yes.
Yeah. So I've been in charge of our core facility since 1999, and it kind of came about as there was a huge growing need at the NIH, a lot of investigators who wanted to use fMRI, and instead of sort of having a parallel sort of capability, just having a core was useful. And just to start, I just like to just start with the people in the core. I mean, it's a large core, and we service about 30 PIs, and there's about 70 different protocols being used on the scanners, 5 scanners, and I'll go into that in a second. But we really do need a team of people, and to the extent that this can apply to the extramural program, it's nice to have, essentially, initially the formula was, 1 physicist per scanner. There's obviously some economy of scale as you get more scanners. Since we have 5 scanners, we have 4 people, 4 physicists who are pretty busy in handling everything with regard to that. A lot of our users, which really helps also in keeping things standard in terms of keeping all the equipment in place, keeping all the protocols sort of in place in the scanner, and also keeping the various forms they have to fill out sort of in order. We have technologists that sort of help keep that order, and also help people scan if they need help scanning, if they don't have a person that can scan. We have technologists. So we have 6 technologists pretty much working full-time, handling, picking up where the various needs are. And we have an IT staff. We probably need another programmer here just to help with what I'll get into. So we have 5 scanners right now. 3 are 3 Tesla, and what's interesting is that 4 are 3 Tesla actually. We're going to have only 3 in a second, but in a couple of months. But we have both Siemens and GE, and the reason we did that was more, I would say, sort of historical in some sense. We started out with GE. We have a good working relationship with GE. But also Siemens is certainly, I think, probably a little bit better in terms of sharing and disseminating and getting pulse sequences that are already available. We have a Siemens 7 Tesla. We're going to actually replace one of our 3T, and we actually have one scanner, and this is actually important as well. We had one scanner that was sort of kept constant. We didn't upgrade it. We kept the protocols the same. We kept the hardware the same, just for a lot of our longitudinal studies. There were some longitudinal studies that needed stability over the course of maybe 5 years, and we kept this scanner constant. We're going to upgrade that to another. We're getting another 7T, and generally the users, as 7T becomes more turnkey, the users are using it more. It's obvious, the advantages are obvious. We're not going to get into that, but and this is our center. So we're kind of lucky in the sense that we have we're part of a larger NMR center that has cardiac scanners. There's NIAAA actually has a scanner, a Prisma. We're associated with NINDS, which is the lead institute for the 11.7 Tesla human scanner as well, that they're getting, that we're hopefully will be ramping up very soon. There's also a mouse imaging facility, and the NMR Center, which is not part of our functional MRI facility, has a 7 Tesla as well. So with all the scanners, you need subject interface capabilities. And we have, one of our physicists, actually Sean Marrett, is sort of the lead person to sort of, and also Vinai Roopchansingh are the lead people to sort of handle all this audio visual button box. And what's nice about this is that the groups actually don't have to necessarily get their own stuff. They might, and but a lot of times this equipment is useful for other people. And so we try to consolidate that with the core and keep it available. And we're also working on simultaneous EEG and fMRI as well. So I won't get into this too much. This is sort of an ongoing challenge to have the IT infrastructure such that the data are backed up and archived appropriately. Nothing's lost. But at the same time, we don't necessarily guarantee like infinite storage for everyone. They have to eventually take it off the scanner and use it. But we do, that said, we have been pretty good about keeping long-term storage. This is sort of an ongoing challenge, which we'll probably upgrade soon, either using Flywheel or something. So having a facility is more than just keeping the scanners operating and trying to keep them at cutting edge, which is potentially a full-time job for most people who are handling that as well. But it's also either assisting people in basic scanning or collaborating with them. For instance, if they need a specific pulse sequence or a specific protocol, or they need a strategy for working, getting some type of information, we collaborate with our users as well. And if we collaborate, we expect to sort of be part of their papers and ongoing work in that sense. But for the most part, we just simply make the scanners available, and so we don't ask for any scientific credit in that regard. We also scheduling the technologists, scheduling, having a web interface for scheduling time, and as I mentioned, data support is a huge, hugely important as well. So, and also we have seminars and training. We had a summer course that's sort of not going on right now, or hasn't been going on for the last couple of years, but it will be probably starting up in some version again. And all those courses are online and archived, and that's very helpful for our users as well. So with that, I'd just like to, and one thing that I want to mention as well is that along with the core facility, we have a machine learning group, a data sharing group, and also sort of a growing center for multimodal neuroimaging. There's people who do TMS in the scanner. They other people who with other modalities, MEG and PET and EEG, want to figure out ways of interfacing. And also, this is also through the group that runs AFNI, the Scientific and Statistical Computing Core. So we're lucky to be within a well-supported infrastructure, and this is how it's different than extramural in the sense that a lot of this, this is all pretty much hard money, and I would recommend that if you have a core of this size, you really do need stability. You need people who are not dependent on necessarily getting grants to provide service. You have to sort of have this critical mass of people that provide service, and maybe in the extramural program, it might be that the formula might be that they are part of a certain percentage on a grant, but also it'd be nice to sort of try to get more hard money to support this, because it really does. It's an investment that provides value in that regard. So with that, I know that there's some discussion about QA. We actually do QA on all our scanners every day, and it's not anything fancy. It's basically just putting a phantom in and doing a basic signal to noise assessment, or temporal signal to noise assessment and ghosting assessment. And it could be more. What we would like actually is having some sort of, we've talked about this as well, having for each time series, having metrics that come off the scanner that assess many different metrics, like physiologic noise, signal dropout, warping, ghosting, and so on for every time series. And that doesn't seem like it would be, it's in theory pretty straightforward. It's actually in practice, it's probably more difficult, but I think that's worthwhile, especially when we've had situations where people have collected 200 subjects and really hadn't looked at their data. Then they looked back and they realized, oh, these data are, the subject moved too much, or this is pretty low quality. So it's nice to be able to have those metrics, and you don't have to sort of dig into the data and really analyze things closely to figure out what was good or bad. You just have those metrics. So I'm pushing to get that going as well, and obviously collaborating with the AFNI group as well in doing that. So that's pretty much it, right? Okay.
Thank you so much, Peter. Perhaps we can go to Robert.
Okay. Hi. Thanks for the invitation. Let me see. Can you see the screen?
Yes.
Yes.
Okay.
Yes.
Okay. In my talk, it's also very quick. I actually, as I'm not the head of the facility, I was more concentrating on safety aspects and QAs while doing the daily operations with our scanners. But at first, also a short introduction. So we are part of the Max Planck Society, so which in its core is maybe similar to the NIH in that regard, that we have many institutes distributed over Germany, and we are doing basic research. So that's also one thing to keep in mind when it comes to running our scanners. And at our institute, we are investigating the human brain, so we are not doing any animal studies, which is also important to know when it comes to the safety aspects and QAs maybe. And we are focusing on structure, function, plasticity, as I said, on the human brain. And regarding the MR infrastructure, first of all, I wanted to mention the two most important people in that regard. So that's Professor Moller and Professor Weiskopf, which you can see here by developing or constructing the connectome scanner, just by helping to bring it to our institute. But we not only have the connectome scanner, we have a few others. So I like to group them. So one is, of course, the beast with the maximum gradient strength of 300 millitesla. Then we have our 7 Tesla system, which we have the new Terra system since last year with the PDX option. And of course, our workhorses, the 3 Tesla machines. Okay, and now I wanted to talk a bit about safety or procedures, how things are done in terms of staff and volunteers and visitors at the institute. So first, if we have visitors at the institute, so they all have to fill out a screening form checking for contraindications. Usually they don't get access to the magnet room itself, but that could also be arranged. For volunteers, of course, the contraindications form is a lot more specific, a lot more detailed, so a lot more questions are asked. And in addition to the asking for contraindications, of course, they get a detailed explanation of the experimental procedure by the PI and the medical doctor and all that. And in terms of scanning or scheduling, we have a centralized scheduling for all the MR scanners. So no matter if at the 7T or the connectome at the 3Ts, this is all the same pipeline in our case. Of course, it's again different for staff who wants to access or operate the scanners. So people who want to work at the scanners but not operate them by themselves, they of course also need to fill out the contraindications form. That is the same as the volunteers do, not the detailed one from the, the same as the visitors do, not the detailed one as the volunteers do. But then they also have to attend a safety briefing annually, where the most crucial safety aspects of running the scanner are explained in detail. But this is obviously not enough to run the scanners by themselves. So if somebody is interested in operate the scanners without any support from physicists or radiographers, they have to do a training where the part 1 only consists of the general operations, and the part 2 is also including scanning of volunteers, so how to deal with subjects. And if someone did all the training, he gets a test, and then he has the so-called operating license, and he can scan volunteers by himself, or if he only participated in part 1 of the training, he can at least scan phantoms and maybe post-mortem material. In terms of QA, one more thing. If we have additional software or hardware, of course, only trained physicists who participated in the IDEA programming course can do modifications of the software, and every additional hardware has to be tested in terms of safety, artifacts, and all that. And if it's a major upgrade of the system or major change of the system, of course, we have to update the subject information, maybe apply for ethics committee, or possible extend our insurance or volunteer insurance. And now to the QA. So we do it not daily, but once a week. We use the Siemens Orange Phantom, and our workers is the EPI time series, which we run. It takes about 20 minutes each. We also look at the different channels, do an RF noise test, and do this, of course, the normal Siemens customer QAs. And at the connectome, we run an additional QA checking for the gradients, so looking at a specific DVI acquisition with a B-value of 5,000. And then we analyze that is automated, so it takes a ROI, and then it looks for SNR, TSNR, stability, does the Weiskopf test, all these kind of standard measures. For the DWI, it checks, of course, also for the SNR, but then also for eddy currents, FA, ghosting, these kind of things. The flash with the separate channels, we look if there's some, this is a visual inspection, we look if there's some odd signal in a specific channel. And of course, in the noise test, we look if there's any interference, especially if some changes at the system was made. Okay, I think that's mostly it. Thanks for your attention. And yeah, if there are any questions, you can do that afterwards. Thank you.
Thank you so much, Robert. That was fascinating. Next is, I think, John, you ready?
Yeah, sure.
Yeah, go ahead.
I'll share my screen.
Yeah, we can see it.
Yeah, okay. Yeah, so thank you very much for having me. So I would, I guess, repeat a lot of what Peter had said and Robert. We have very similar setup at the Martinos Center at Mass General. So I really wasn't quite sure what content I was to provide for this brief talk, but I was told QA, so I just wanted to provide for you our daily QA that we do at the Martinos Center. So, but a lot of what we have at the Martinos Center is very similar to what Peter was describing very nicely, and also Robert at Max Planck. So I won't go into those types of details. But here we have, just real briefly, we have eight imaging systems, human scanners at our site. They're all Siemens. We have 6 3T Siemens scanners, a whole variety that have different capabilities. Each, we have one Prisma Fit, which is pretty standard. The Skyra also is relatively standard, and Tim Trio is pretty old at this point. All 3 of those scanners are pretty much standard 3T types of scanners. We have a brain MR PET, which is based on a Tim Trio configuration, and also a Biograph MMR, which is Siemens whole body MR PET scanner. And then our 6th 3T scanner is a Connectome, 300 millitesla per meter, which is going to be replaced by a Connectome 2.0, which is a collaboration between Martinos Center and Siemens to increase the capabilities even further. We also have 2 7T whole body scanners. One is the 7T Classic, which actually was serial number 1 for Siemens in the US. And then we also have a 7T Terra, which was installed about 1.5 years, 2 years ago. So I was just going to give you a couple slides on what our daily QA protocol is and testing that we do. This was historically developed. I was with Siemens for quite a bit of my career, and I was recruited to come to Mass General to collaborate with Mass General. And in the early 2000s, there was very little being done yet at 3T, and people were still trying to figure out fMRI, at least with respect to optimization. And so a lot of what I did with the Mass General people was to really focus on how we could improve the quality for fMRI. So I did a lot of work on the preliminary development of this. And so there's some similarities to the FBurn procedures. Other people have very similar things as well. I apologize that there hasn't been much improvement over the years of this. It's something that I wish to focus on and have a lot of interest in hearing what people have to say here. But the protocol is like what everybody else typically runs. Is it's a 500 time point FID based EPI scan, multi-slice, TR of 1 second, 30 millisecond echo time, 90 degrees. We don't do any acceleration. So I wanted to point out that this was sort of developed as a troubleshooting tool, at least from my perspective, and not so much necessarily a QA tool. So what you'll see in terms of how we evaluate this stuff was primarily meant not to necessarily follow trends, but to also glean information about what might be wrong. So a lot of my involvement at the very beginning had to do with hardware instabilities, environment instabilities, anything that can confound the fMRI scan. So that was my goal, and it's what a lot of this was developed on. So it's a standard type of scan, 500 repeats, 8.5 minutes typically, and we do this in succession 2-3 times on a daily basis. The outputs, we have multiple types of outputs. Thomas Benner was the person who originally automated this procedure. I worked very closely with him on developing all this stuff at the beginning. And we get signal intensity plots out, we get SNR plots, ghost plots, and then we have some analysis, preliminary analysis, to allow us to sort of get an understanding of what may be wrong, if in fact something is wrong. So we have subtraction maps, we do ratio maps or division maps, mean maps, standard deviation maps, TSNR maps, and then finally a Weiskopf plot, which is based on a paper that Robert Weiskopf had developed back in 1996. So the signal intensity plot that we do is just simply an ROI that's fixed at the field of view center. Each slice is evaluated. We have this color-coded and detrended in order to extract and remove slow trends in the data. So we have a quadratic fit that's done on this. And then we showed both the acquired SI as well as the fitted SI. And then we do some just rudimentary statistics on it, peak-to-peak variation in percent, standard deviation, et cetera. And then this is showing a relatively typical result, relatively normal result. Output is showing that the peak-to-peak unfitted is around 0.2%, and then fitted is about 0.16%. And this is just an example that's bad. So this is showing some real instabilities. And so if the output is greater than 1% peak to peak, then it's put in as a red plot to sort of give us an idea that something's wrong. This is a very obvious wrong issue. Sometimes it's a lot more subtle than that. We do an SNR evaluation. The output is just SNR versus time for each slice. Again, the same ROI at the field of view center, and then peak to peak variations in percents. This is showing a very typical result. This actually is kind of interesting, is also that really bad result shown previously. So it doesn't necessarily, and that sort of spike temporally is actually not correlated to the spike that you saw in the signal intensity. So it's not reflecting actually what's wrong here. So it may or may not, but typically the SNR evaluation doesn't show those sort of things. Ghost evaluation, everybody also does this for the Nyquist ghost. We look at this temporally to determine if there's any fluctuation that's going on with it, as well as the overall intensity level of it. We do some standard statistics of this as well. And this is the typical result. This is now showing that bad results. And so that bad results, and this is actually recently, not that long ago, on one of our scanners, on one of our older scanners. So you can very easily see there's something fundamentally wrong here. You have ghosts that are extremely high and is very erratic. So that's basically what the problem was on this particular case. We do subtraction maps, and we do this to sort of get an assessment of temporal geometric variations that may be occurring. In some of these older scanners, you have some B0 drifts, long-term B0 drifts that can occur, which causes a translation, 0th order translation of your images. And so that would be reflected. If you have instabilities associated with the gradient amplifiers or the gradient coil itself, then that's going to exhibit itself a little bit differently as maybe first order or even higher order spatial variations. So we do subtractions on maximum versus a reference, and we always just use the time point 3 as reference, just arbitrarily. And then we look at what the outliers are doing on this map. And then this is that bad result. So very clearly, this is showing we have some N/2 major issues going on here. We do a subtraction map, which is very similar, but now we're looking at the outliers on the negative side, it reduced signal versus increased signal. And then this is that bad result. So it's showing that basically, you know, we have real variations that are going on that are not just the increase in the n/2 ghost, but also stealing away from the primary image itself. Division maps, we do ratios. This is meant primarily not so much for spatial, so subtractions might give you an idea about received path signal fluctuations and or geometric issues. We do division maps primarily to see if we visualize transmission related issues. So we do, again, a ratio of maximum outliers relative to reference and then minimum outliers relative to reference. And then we just simply do a mean map, which doesn't really give you too much information, but we do that anyway since it's trivial. This is the mean map of the other bad result, which sort of looks interesting because it has a bit of shading here, but that was actually a part of a troubleshooting exercise in order to track down this n/2 ghost fluctuations. And it turns out this the actual source of the n/2 ghost was the upper half of the head coil. So upper half of the head coil is being represented here, so you don't have the posterior side. That's why that shading is there. Posterior side was very stable. The anterior side was very unstable. And then we do a standard deviation map, which ultimately is done to give us a TSNR map. And then this is that bad result, which is pretty bad, but that's understandable as far as what you saw in the original signal intensity fluctuations. And then we do a Weiskopf plot that shows both standard deviation as well as peak to peak in different color codes. And of course, you're going to see some pretty bad results related to that n/2 ghost fluctuation. So this is just showing you that some time points, 20 time points out of that 500 time points. We have a very large and obvious fluctuation. So a lot of times the data is much more subtle than this, but this was just an example to show that show you the difference between a normal typical run and something that shows wrong behavior. Okay, so and then we have a list of people in our core facility that get automatic emails of just the number outputs of these things. We have this done so that we can sort of keep track, and then if we see that some of these numbers are really incorrect, then we go to the system and actually look at the data. So that's pretty much it. Thank you very much.
Thanks, John. I was just going to chime in if there's a time. I don't know. So
absolutely, go ahead.
Add a little bit of historical perspective. A great overview, John. That basic protocol was running when I arrived at MGH in 1995, and I think it had been running for many years since then. And it's kind of maybe a good question for this group. You mentioned it's probably time to update it because it's a pretty old-fashioned protocol. And I just wanted to say that's an interesting point for discussion because having that long historical record actually is very helpful. And if you're always updating it to the latest sequences, it's hard to do that. The other thing, that automatic report is just critical in my mind. I remember getting those emails every morning. First of all, you can tell that the tech ran the QA. So that's step number one. And you can be on the beach in Hawaii and check your scanner's QA. It's just really, really critical. And it's something that like Siemens, I'm not sure that they actually do in their basic QA runs because they don't like to run an email server on the scanner. But and also generating it into DICOM plots so that they're archived forever in our standard image archiving, all those plots and stuff. And I just wanted to bring up two other points that I have always kind of nagged me over the years. And one is a very simple low-hanging fruit to add would be something with gradient scaling. So, I've come in the morning and looked at the Phantom and said, why is it not round? I know that's phantom spherical, and it's because one of the service people has somehow set one of the gradient scalings wrong, and suddenly you have an oval phantom. And that is just terrible for things like a longitudinal study of cortical thickness or something. It just is death to a study like that. And it would be like, I think, a really easy thing for us to catch. The other thing has to do with the phantom itself, and that is, I've over the years just become not a big fan of uniform phantoms. I mean, that phantom is a delta function in K-space. That doesn't represent brains. It's just not very representative of what we do. And that really catches up with you if you start to do grappa or something like that on the phantom, where you have to fit, a kernel across K-space. Well, K-space is just one delta function. You can't fit a kernel. So I kind of wonder whether it's time to move on to, if it has too much structure, it might be problematic, but there must be some happy medium. Anyway, those were the only points that I wanted to add. It's a great overview of long-standing tradition, and a very happy day when Thomas Spinner updated it so that the data didn't have to be pulled off every morning and analyzed. I used to analyze it in IDL.
Thank you. Those are perfect questions to segue into our open discussions. It's kind of funny how the three centers presented very different views of the processes. So I'm sure there's a lot of questions. So any questions, or I can go ahead. Cyril, are you raising your hand? Or?
Yeah, I was. Oops, let me see. I just have a question for the three actually presenters. How much of when you run like this kind of QA, the parameters that you use reflect what, say, most users would be using? Do you just do like this is your standard, or is it like more let's change the TR, let's change the FOV or stuff? Well, the FOV is for the ball, it's just always the same, but like say the TR, or I've seen there for the Martinos, for instance, you were mentioning not using SMS, whereas I would imagine that most fMRI studies nowadays are using SMS. Just, what's your ideas about that?
Yeah, I think Larry touched on that a little bit. That's what we're running right now is not necessarily realistic. This is for sure. In one sense, it's been nice because we can track over a long period of time consistently what we've done. But at the same token, if it's not necessarily representing what's being done clinically or in actual human studies, then that's a point of discussion for sure, especially when you introduce SMS and acceleration techniques and this sort of thing, which can definitely affect it.
Probably the right thing to do is like once a year, update the QA and then operate with 3 months of overlap where you have both the old and the new. And that way you always have, sort of 3 months of history to compare to. That history has been incredibly important to us in dealing with the vendor. We say, oh, look, it's, the stability is 1.5%. We want it to be, 0.5 or less. And they say, oh, it meets all of our QA. What are you talking about? And really having that historical record, and you can really show them. In our experience, my experience has been very helpful. So I don't want to lose that historical record.
That's actually very true. And one quick thing that I wanted to actually point out that we're not doing these QAs on our 7T scanners. And the specific reason for that is because the phantoms that Siemens provides for the 7Ts are really not appropriate for this type of test. I believe, if I remember correctly, there's 2 phantoms. One phantom that has a really nasty double resonance, and that can prove disastrous. And the other phantom has ridiculous relaxation times. And so those 2 together can lead to really, really erratic and unpredictable types of results that have nothing to do with something wrong with the scanner. So until we determine what is going to be the best type of phantom, and what Larry said is also true, that these phantoms with just a flood phantom is not necessarily the most appropriate for this type of test and QA.
Yeah, there's some other reasons why we haven't historically run it a lot on the 7T, but
Yeah.
yeah, getting phantoms that fit the coils, some of these larger spheres just don't fit in our, helmet-like coils. But, the F-burn phantom works in the 7T.
Yeah, I guess with the QA, I mean, right, you want to hit, the maximum sensitivity to other sequences or things that could go wrong, but also you want to have it generalizable enough that, it does apply. So, and that's kind of tricky. I mean, you could imagine, I mean, there even, right, if you go to certain higher resolution sequences, you might get mechanical resonance with the gradients, and that throws things off. And so it's hard to make the perfect QA, but right, I mean, you sort of have to find something as minimal as possible that gives you some sort of sign that something might be going on.
Yeah, the same here. So it's more like having a baseline and then checking if something goes wrong. So it's not really, I don't think it reflects most of the studies, especially at the 70 in terms of resolution and all that.
I had a question related to kind of the automation, but maybe first I'll give a brief perspective. So I run a single Siemens scanner center at University of Washington, and I'm basically the only full-time employee. We have a director and then a technologist. So, and I'm very interested in facility QA, as I've been kind of, but I'm not a physicist. So I've started as, I'm a cognitive neuroscientist, and I got interested in how magnets work in grad school, and that's kind of now what I do. But I'm a small operation. So like my QA routine, just to kind of briefly give, is we do a daily routine where we do basically the Siemens coil check and then a couple of warm up and a couple of runs of EPI. And then we do a weekly, much more thorough, where we check all the coils, do a lot of environmental recordings and stuff like that. It takes about 2 hours. And then every, week, couple of weeks, I'll run through the entire Siemens kind of factory, what they do for their PM, which is about an hour. But one of the main things that I think it's really interesting that Larry brings this up, because I totally agree, is the ease. It has to be a low barrier to entry in terms of getting QA to be done more widely at smaller centers, where it's only a single magnet, possibly busy and with lower staff. And like my daily routine is basically designed so that you can put the phantom in and not have to move it. You can run the coil check and then run the EPI sequences, and it takes 10 minutes, and it's a low barrier for the technologist. So following up on that, is anyone, I guess, besides MGH, have automated routines that just run on the console? Because I think that's something that's like, I don't know if you guys offer that as a whip sequence or not, but those kind of output to DICOM seems great, right? Because like you said, it's then archived forever and you have it. The alternative is what I'm looking into, since we have Flywheel, is getting an automated routine on Flywheel in a Docker container that can then run basically either a standard F-burn analysis or something like that. But I feel like with smaller centers that have limited staff and resources and are trying to serve their users, this is a huge service to users to make sure that the equipment's running right, but fixing the button box is sometimes a higher priority in terms of cranky PIs. And so that as easy as we can make this to do and as automatic as we can make it, that seems like a great thing. So it'd be great to hear about ideas from maybe the bigger centers on how you do that, and or if there's ways that we can make this more friendly to smaller centers as well.
Go ahead, anybody.
I just say getting the analysis, completed on the scanner, so it, generates plots and stuff, is a big step. And I'm not sure how available that is. I mean, the person who did that is now at Siemens, Thomas Spinner, but
Yeah, we support that, Larry.
Yeah, okay.
We do support that. We provide that as a C2P for anybody that
So
requests.
that's an MGH C2P.
Yeah, correct.
Oh, okay, that's great. Okay.
That's good to know. Yeah, does it have the email function in there, hopefully? That,
No.
That's so painful.
Yeah.
Okay, maybe there's some way to.
Well, it helps though if the DICOMs get pushed, because our DICOMs have to start.
Well, yeah, just, yeah, no, it's fine.
So we also, I mean, we have an automated, I mean, basically the scanner, the technologists just run the scan and we get an automated PDF sent to us with plots and various metrics every morning. So.
And is that on the scan from the scanner, Peter, or is that something offline?
No, we
server.
It comes off the server. It's off the that is basically analyzed from our repo.
Okay.
So we identify those, we label those, and they basically get, 10 a.m. every morning, we get an email with all 4 or 5 QAs.
So I guess there needs to be a distinction made between pipelines running on the scanner live or post-acquisition. As I understand, I think the FBurn and other pipelines that run on XNAT or similar databases run post-acquisition at some point, either on the same day or sometime during the week, right? So the simple calculations of QA is rather kind of solve problem in terms of applying FBurn pipelines or anything else that you like, right? Is it more desirable to do it on the scanner just so you get it quickly right when the subject is there? Is that the question?
Sorry, I think most people run these in the morning before the scanning begins. So there is a really nice series by Ben Inglis back in 2014 in his blog on sort of a theory of QA. There was sort of basically what are we aiming for? And he distinguished between facility QAs and user QA. And the facility QA was, as John sort of really nicely demonstrated, aimed at highlighting systemic issues with the scanners, and the user QAs were basically just to demonstrate that the scanner was running and acquiring good information at the time of acquisition. And I think some people are now trying to do more sophisticated, like MRI QC based analysis in quasi real time immediately after each acquisition. But those are two distinctions, I think, between facility and users.
Yeah, like, we talked about dynamic phantoms too, right? That they're trying to acquire right before the resting state of fMRI acquisition. So they can match the state of the scanner as much as possible to the exact session that acquired the human data. Because I think the claim is that the scanner properties change even during the day, and they want to try match it as much as possible. But I think it is some people do not agree with that.
So Sean, following up with that, so do you have those routines on like a GitHub repo or something that is public, or is that internal to NIH?
I'm sorry, the
like the automatic routines,
QAs that Peter,
email and all that.
That is a good question. Whether it's in GitHub right now, I believe it is. One of my colleagues, Vinai Roopchansingh, has been very good about putting those things out, and I think he redid those. The big issue for us, I think, is that we're still not, I think, handling multi-channel acquisitions. Like if you actually want to sort of identify a particular element that may have gone bad, right now I don't think we're doing a great job of that. That's a work in progress. I believe that is actually in our GitHub repo.
I mean, that's great. So one thing I'll say about the smaller centers, I think, as potentially a larger group that we can do is putting things like that in public repositories, even if they're not the most polished, beautiful code, is like a huge help to centers like mine and a lot of other smaller ones where we just don't have staff to do that. And even if we're not necessarily at the point where everyone with every Prisma or every magnet's running the same thing, that's a big help. And kind of to address Pradeep's question, I think probably offline is usually the way to go, and that also makes it easier to do cross-platform. So with Philips and GE scanners, I would say, right? Because if we're doing the same analysis on the same data offline on the console, and a lot of us just don't necessarily have access because we don't have the relationship with the manufacturer, that some of the bigger centers do, to be able to get that running on the console. So I think people sharing off GitHub repos of whatever their QA routines are would be a great kind of thing to kind of kickstart this discussion and move forward.
I'm happy to help them make them easier to use and maintain, as are many other people in our community. So Harold had his hand risen. Sorry, go ahead.
Muted.
We can't hear you. You need to probably choose the right mic. Sometimes Zoom does whatever it likes. Yeah, maybe until he figures it out. So it's kind of very interesting to me so far that what I thought was much more commonly used and being used in terms of the Snr database, the FBurn QA pipelines, etc. So it seems like there is a need to somewhat harmonize. I haven't seen these subtraction maps or division maps before, partly because I may not be an expert, but I think they seem like quite a useful QA QC tool that need to be shared and more widely adopted. How can we improve this harmonization? I was one of the motivations to do this was to try identify open challenges. So maybe I guess we can, one of the challenges seems like harmonizing how QA is done, even if they use different metrics and different hardware, and kind of set up some rough thresholds, so to say, right? Any comments, Peter, Lawrence, or Harold, Nick?
Yeah, I think even before harmonizing, just getting it out there, just maximizing the distribution.
What do you mean?
I think it's pretty clear that even we don't know exactly which of our tools are available, for download by and sharing by others, and exactly how to, go about that. So if we don't know it, the rest of the community doesn't either. It just struck me that somebody brought up multi-channel, multi-coil evaluation. We have a QA that we actually run quite regularly on 7T that is a full QA of the multi-channel coils, looking at noise correlations and as well as Snr and G factor.
Yeah, I didn't bring that up here specifically, but we do, in addition to the temporal stability assessments QA, we do like Larry said, the daily QA. Actually, we do that on all the scanners, not just the 7Ts, for assessment of the coil and multi-channel capabilities, as well as external RF interference as well. So I just didn't talk about it.
Yeah, it was sadly, especially for the 7T, the coil is often the thing that goes astray. I just wanted to focus on this idea of what's done as a facility and what a user should do. I think somebody pointed out that, we run these in the morning. And so we basically tell our users, the scanner was working, at 8 a.m. this morning. They're maybe taking a scan at 8 p.m. Maybe they should repeat, a 5-minute mini QA and a phantom while they're consenting their subject. I would say that's kind of up to them. And I think, Peter, you mentioned the users who don't look at their data for a year and a half and then are shocked to find that it's all bad. I just can't find any sympathy. We face the same people, and I just can't find any sympathy. These are scientists. I mean, give me a break. They need to look at their data and do some basic QA themselves. I mean, this is not a nursery, Anyway, I'm being kind of harsh.
Yeah, no,
I introduce. Go ahead, Peter.
Yeah, no, I think, right, through working with one of the scientists on this, I realized that, right, you can do QA, but still the data might be bad because of some specific type of sequence or some parameters that they used. And that's why I thought that it would be even more useful, right? Like I was mentioning before, instead of having, it would be great to have first, whatever QA is being done, put out there for other groups. But secondly, it'd be nice to harmonize this QA. But third, I think that, especially if we're doing, data sharing, it would be nice to have something, and we've talked about this, is have something, not really a QA on a phantom or anything, but just simply having the basic metrics of what makes high quality fMRI time series data for, it could be, put into the header or some sort of file that could be generated pretty quickly for each time series. And I mean, it seems like it would be generating a lot of data, but I mean, I think that could be, you can imagine before you deposit data into a database, some sort of overall database, you could imagine requiring that certain metrics are above a certain level. So
yeah, no, that would be super easy. I mean, like if the image recon, you're spitting out the time series of hundreds of images, if it just spit out a TSNR map and a variance map, as image number 1 and 2, that would be awesome, because at a glance you could pretty much see where you stand. Yeah, no, I take back what I said. That would be an incredibly useful thing to add to every sequence.
Yeah, I mean, that also raises an interesting project for developing a structure for QA/QC reports at the subject level as well as at the dataset level. I think, some of it is done by the tools before the process, but I think we need to think about what is acceptable, what is not, which is still an open question for a lot of these things. Harold, can you speak now? Is your mic working?
I just switched my system, so I think it works now. I had 2 questions, basically. One from the discussion, I mean, in Germany, with among the high field centers, we agreed on a certain phantom and ran a number of tests on every system, even in vivo tests, but like on a small scale, that works not worldwide. But it would be nice to have even a minimum test that is run at many centers in the discussions with the vendors. If you feel your system is not behaving as it should, you may be, and they argue, okay, that's within specs. But if you say, okay, I'm off and 90% of the others are doing better, it's certainly something that you don't find immediately. And the other thing that occurred to me is many of the tests that we are running are mostly motivated by fMRI protocols, because we had to make sure that we find relatively subtle activations. They are not necessarily the best for longitudinal studies, and it seemed that NIH is running a relatively old system, MGH, even a TRIO, and we have our Vario that we will retire soon. And we, for example, have been running a longitudinal study that was not planned to be one. So to have a very simple test that is more targeted at structural imaging also would also be nice.
Yeah, that actually reminds me of the question we had from Lars Kasper. He was asking if there is an equivalent of FBurn for diffusion imaging, Anyone want to answer that?
So, if I understood it correctly, so the question was, are there established quality control protocols for diffusion imaging, right? I mean, I'm aware of there's a paper by I think Sandy and Derek Jones on QA protocol, and I think appeared in MRM a few years ago. But I think they're by far not as established as the FMI QAs we talked about today. And Robert also briefly mentioned it, that for the connectome system, we are also running a QA protocol. But there you have to, again, think about the phantoms more carefully, because with the high diffusion weightings, you get very low SNR. So you need, low diffusion phantoms that might pose an extra challenge. And of course, there you even have more degrees of freedom. So we were discussing quite a while what would be best, but I think what we went for in the end was more the pragmatic approach. Do something with a reasonable B value, so you challenge the system a little bit, so to say, don't make it too easy, And then you look at some stability over time effectively. So different directions, different, but I think that relies a little bit on the concept. And I think the same is true for a lot of the FMI QA protocols, that if it breaks in a way that it's relatively easy to see. So, you know, if you have an issue with the gradients, it appears in any EPI protocol, in any anatomical protocol. So same hopefully would be true. Let's say you do diffusion imaging, you have problems with eddy current correction or something like that, eddy current compensation, and it would also appear in almost any of the protocols, so that the impact is relatively high. Which I'm a bit concerned about, especially with the advent of so many new technologies. I mean, some were mentioned in terms of the image reconstruction, SMS, multiband, different parallel imaging procedures, but also in terms of the hardware. I mean, for example, on the 7 tester, we have PTX, we have now multiple transmit channels. So it's not only about now QAing basically the multiple received channels, but also the transmit ones. And they bring in a multiplicative factor. So that's the issue. You have kind of 64 chances for getting something wrong, not only one like in the past with a single channel system. So I'm not sure, but to me, it feels like whenever we try to kind of build QAs and use them more regularly for these more specific aspects, it got harder and harder effectively, and you get deeper and deeper into the system, becomes more specific. For example, then much harder to roll out more broadly internationally, for example, to many sites, because you get so deep into the system's operation and details, and potentially also proprietary information.
But it's also an issue of the time that you want to spend on the QA, because I mean, then you're all in competition with people who want to run their studies, that there's only some time that you can devote to QA. And if it's too specific, I mean, you won't run 2 hours every day just on QA, because it just doesn't fit into our schedules.
I mean, related to that, though, I think there are things that, again, the expertise in this group can contribute to what kind of everyone can do that might be fast. So like specifically with the multi-channel coils, we run the Siemens coil check every morning as part of our standard routine, because it seems like, at least in my experience, those coils having one channel go bad is not that unusual. And sometimes like we went through a number of coils, the LC dyne, BC dyne issue, and those aren't things that are necessarily super obvious on day-to-day images. And also, if you rely just on manufacturer PMs, I'm pretty sure that Siemens only checks that once or maybe twice a year with their safety PM. But that's a 5-minute, coil check takes 3 to 5 minutes on a Siemens scanner. And I think at least for the kind of imaging we're doing with fMRI and multiband and whatnot, that's one of the kind of critical things. So I think that we can potentially, this group identify, okay, here are some key metrics that are low barrier to entry and low in time. I mean, the other one that we do that I've done in the past is just recording the kind of standard transmit voltage on a Phantom, right? And that seems like, I've talked to Ben Inglis about this, it's a good indicator if your gradient coils sprung a leak and you have a crack, right? Because you start pushing on the body coil and your voltage is going to be all over the place. That's something that, again, takes about 30 seconds and can be included in a morning thing, and is kind of a critical system aspect that, again, this, at least my experience is the system itself, we had a leaky gradient coil for a number of months and didn't know about it until finally we got body coil error. And that, again, is kind of a result more of the kind of imaging that we do with lots of EPI and fMRI. It might not necessarily be in the kind of standard routines that are done by manufacturers for clinical imaging. So that a list of those kinds of 5-10 parameters that we think are most important for doing the kind of imaging that we do would, I think, be really useful to the community.
Yeah, I agree. I think we should have some minimum level of QA QC be done. But it's interesting, MPI does only weekly QA. I was wondering if there is any danger to doing weekly instead of daily. Have you guys run into any issues, Nick, Robert?
Yeah, I mean, of course, it's 5 times higher chance that you, or even 7 times higher chance that something goes wrong. But as Larry said, it could also be that it's in the morning, okay, and in the afternoon, it's, I mean, you don't lose that much data, but so far we didn't have, as far as I recall, at least, a lot of data gone to waste because of that. So it's also
there's also some different aspect to it. For example, if you're running different coils regularly, that multiplies into the time you have to spend on your QA. So there are many issues to that. I mean, even if we only do brain imaging, which makes it easier, it's not that straightforward to test everything every day.
Yeah, also the multi-channel and the single-channel system, to switch between them, it takes a lot of time, and so it's just a practical question.
Yeah, so Larry was talking about the importance of historical data, right? So I think if we had access to the historical data from all scanners and all coils, perhaps we can find a window of potential failures and what's the minimum window we need to check to catch the issues, although I guess hardware is changing and environment is changing, so that might not help. It's good to know that MPI hasn't run into any major issues despite running weekly QA.
Is it true that the FBurn website, at one point they were collecting multi-institutional data, stability data? I don't know if they're continuing to do that. Does anybody know? That was relatively useful because you could see across vendors, the variations, the differences. And it was quite a large database that was being collected, but I don't know whether that continued or not.
David Kennedy, do you want to answer? Do you know? Or Yarik?
I don't know the answer to that.
Me neither.
I know that now Javier Goet and Gold Standard Phantoms are kind of doing the same thing with their Phantom, at least, where they are collecting, and because they're offering processing for their Phantom, which is basically the FBurn routines. And I think that they are open potentially, I shouldn't speak for them at all, but you know, with sharing or finding some kind of cross-site or cross-manufacturer metrics, that would be, I agree, a really useful thing.
So in Toronto, Stephen Strother, my postdoc advisor, they built a system basically the monitoring all the metrics that are computed by FBurn and other protocols, right? So there are aggregators like that, like Loris, and even probably XNAD itself has facilities to track it. We just probably have to organize it in a way. And Yarik was interested in building such a clearing house to collect all this in a centralized place, but that has a bit of a challenge in terms of people need to be willing to share their QA data openly, and not everybody is as excited because they're worried that someone will find an issue with their project data. I support it. I think that's the way to go. All the open data sets, we probably need to just pump out QA data as they're acquired and leave it open for research. You know, I think that's the future. We need to get there though.
I mean, I think that would be great, but one thing about that is finding thresholds that, for people who don't want to share their data, if we can, for those who do, if we can find threshold for certain measures that kind of we can use as benchmarks to be aware of, because there is sub threshold where the manufacturer doesn't pass their QA, but I think most of us have a higher threshold for those kinds of things. So being able to have some place where we say, okay, if you're running this style FBurn sequence and XYZ metric don't look great, you might have XYZ problem. I think that'd be extremely useful, especially again to smaller centers.
If it's okay, I'd like to come back to this one point that came up before. How regularly should you do QA? And I mean, an alternative approach is actually what So I was at the function imaging lab in London before I went to Leipzig, and what we had set up there was a real-time monitoring system actually to look at data quality, and we tried to come up with metrics that distinguish between, let's say, physiological effects in fMRI experiment. So learning something about how compliant is your volunteer, simply speaking, that part of the QA, versus what is your scanner doing and are there any concerns? And that has actually proven quite useful. So we saw, for example, we had developed ways based on the fact that you oversample most of the EPI approaches in the read direction. You can actually use that kind of oversampled region to look for RF noise or spikes you might have from instruments. And I think that's actually quite a useful combination to have both. Do your, let's say, weekly QA in depth, which is related to the scanner, and have something that actually automatically just runs during every fMRI experiment that tells you something about the data quality and maybe slightly different aspects without. So I think what made it very popular in London was the fact that it didn't impose any additional workload onto the experimenter. It was just automatically there, gave you some kind of difference maps. For example, we've seen this, gave you some metrics, very simple ones, but they were quite useful. The only issue maybe I would see is you have to implement it on site. So it's kind of specialized technology. It doesn't come with a scanner. You need to think about how to implement it.
Yeah, the XNAT-based tools are all already solving the problem for many multi-site projects. You know, I know for sure they do it in Canada and probably are doing it in the US too. So they're not widely adopted, you know, probably because of lack of awareness or lack of resources and whatnot. Any other questions or comment?
I have a question. So has anybody tried to standardize the signal to noise from like a default mode network? So I know phantoms are important, but what about biological signal such as the default mode network? Has anybody tried to standardize and get the signal to noise for that to be optimal?
Well, yeah, I mean, that's the hard part, right? I mean, you know, certainly fluctuations in the default mode network, you know, depend on, you know, your contrast you use, your echo time, your sensitivity to other non-bold physiologic noise. And so, right, people sort of optimize that sort of in an ad hoc kind of way. But I think that what you're trying to say, right? I mean, definitely, it would be useful to try to, you know, maybe separate the noise into. When if you're doing like if you're collecting metrics from a time series with a brain in there, it would be nice to be able to separate, like for instance, the higher frequency noise from the low frequency fluctuation power, and have that. You know, you can imagine coming up with various metrics that look at ratios of high to low frequencies, or, you know, the presence of spikes, or things like that. But optimizing functional contrast is usually just a matter of, you know, echo time, and it's loosely related to resolution and things like that. But yeah, but that's right. You can imagine. So I think what you're thinking is, you know, having a template of the default mode and, you know, trying to sort of increase, I don't know, looking at the low frequency fluctuation power in that template or something like that. I mean, you can, yeah, I mean, once you get started in this path of trying to collect these metrics on every data set, one could imagine, you know, finding their own. They try to optimize for their center, but at least collecting the basic data would be useful even in itself for data pooling. So I don't know if that answered your question or not.
No, that's helpful. One thing that we've done is we've taken the A-BY data set. So there's several sites from the A-BY data set, and we ran our default mode standard protocol on it. And we could see that there's several data sets where there is scanner issues that creep in that affect the default mode network. So we could see that the scanner badness would affect the default mode network. And so we did this from like 900 scans from the A-BY data set. So I think the default mode is a good measure, but I like all these other measures of signal to noise and ways that you can separate. I like the idea of separating scanner badness from physiologic or biologic badness.
Yeah, I would chime in and say that, yeah, it's a good point. I remember sometimes, looking at variance maps and, seeing the carotid arteries, which are incredibly high variance because there was a little bit of ghosting fold into the brain and you can see them. So sometimes just a variance map can tell you stuff, but I think getting at it more deeply, the way to do it would be, to do an analysis of the physiological noise where you vary a parameter, like compare a low flip angle and a high flip angle to separate out image SNR from physiological SNR. Another thing would be a multi-TE sequence. If you had multiple TEs, you could compare variances in the different TEs to try to estimate, the relative ratio of bold noise to other noise.
Yeah. So if you collect multi-echo data, right?
Yep. You'd have to have multi-echo, which of course.
Yeah. You would have that immediately. That's very helpful. I mean, obviously, as Larry was mentioning, flip angle and TR make a big difference in physiologic noise. I mean, you have different amounts of CSF sloshing around. At the edges, you have different amounts of inflow. There's all these parameters that people have been thinking about a lot, but I think we understand it well enough to just have a set of metrics to sort of, characterize that maybe. I don't know if it's totally, I don't know if that's, it's useful and it's great for optimizing things, but it'd be nice just to have some basic metrics though, just to, if you are pulling your data, that then you could use to, optimize your own scans, but still.
So from this discussion, I get the impression that this doesn't exist yet, right? That no one has really standardized a set of human phantom measures like FBurn was. This is not something that anyone's done.
Probably it does. People have been working on it and thinking about this for years.
Right. But,
yeah. So, but there's nothing that you can go to and say, oh, this is the standard thing to do. No.
Sean?
So I'm just wondering whether you're referring to using an anthropogenic phantom or something like MRI-QC, which is, which tried to collect a whole bunch of things from human fMRI data and as well as other structural data. But I guess it depends what you mean by a standard. It's standard as much as it's widely available, but it's not like somebody has blessed it.
Right. I guess, I'm not aware, but I could have missed it, that there's not a paper in the literature that's like, and I'm talking about not for an actual real participant, so that there's not something, okay, if you put a real brain in the magnet, here are a list of 5 or 10 things and 5 or 10 things you should scan and be looking for to see the health of your system on a real brain.
Yeah, no, I think they're trying to MRI-QC provides a lot of that. The biggest issue that a lot of folks have is it's got so many different indexes of quality that it's sort of hard to, separate the signal from the noise in terms of what you really care about. But there is a lot there, and it is fairly standard, and there is a repository as you that people can compare themselves against as well.
Yeah, so that is based on what was once called quality assessment protocol.
Yeah.
I think I forget the original authors.
It was a group from the Child Health, Child Mind Institute.
Yeah, Michael Millam and Kramer and Craddock and stuff. So the quality assessment protocol, there's a detailed list. I think FBurn also touches on many of it. What this sounds to me like, maybe I'm wrong, that there is a clear need to extend FBurn to include, for example, these, as well as other questions we had about SMS, multiband data. We need to add metrics to that FBurn QA protocol. So one of the things I was going to ask panelists and other people interested is, would you guys be interested in working on such an extension to FBurn QA protocol? It's been published in 2012, but I think we can improve that a little bit. Is there a need? Would you adopt it if we do it?
I think there's a need. I think it would be great if you could extend it from phantoms to human brain time series. Even resting state would be useful.
Go back to the question of, is there I don't know. I think most software have something like this. Sean mentioned MRI QC. In AFNI, every time you process with AFNI proc, you get something, and maybe I'll just show, just because the default mode network was brought up, but if you use the known standard space, you get a report like this. And actually we have seed points to show you seed-based correlation for major networks. And I just, because the default mode network came up, this is here. So whenever you process your data, you have the default mode network, visual seed in the visual cortex, and then auditory. And then we have other things like TSNR, motion plots, and things like this. So there's also kind of a command line component where you have numbers like G-core motion, amount of censoring, degrees of freedom, and things like this. So there are a lot of things out here. And again, this is automated. And actually, we've talked with Vinai Roopchansingh in Peter's core about, this is something that could be implemented for every scan that goes on, whether actually it's resting state or not. If you're doing task, you could also do this just for motion and some of the visual cortex. Again, some are task positive, task negative networks and things like that. But there are things out there that do exist like this. I don't know whether we call this standard or not. We use it a lot, and a lot of other people use it and like it. So there are tools out there for this.
Yeah, we're running, which I mentioned in the chat, MRI QC just runs on every single EPI and anatomical data set. We download this because we use Flywheel and it just runs by default. But I think back to a question that was brought up before, is there's the facility QA that I guess I care more about, is running a facility, and there's the squirmy subject. And that's, I think, splitting out the information in MRI QC as to which one of those is which is, I guess, tough for me a little bit as a non-physicist. And it'd be good to have metrics like, okay, here are some facility red flags from actual human brain data that would at least, I guess that's a kind of a question, is that if anyone here is more physics knowledge than I do, or more experience, would say, okay, here's some critical things from a facility standpoint.
I think FBurn QA covered them quite a bit, except for the more recent modalities, so to say. So, right? I don't know, Peter, Nick, or anybody else.
FBurn was kind of a birdcage protocol.
Yeah,
Say again?
What were you saying, Sean?
I was just saying FBurn was a single channel. It was a birdcage protocol. I mean, it was, it did not actually look at, I'd say 90% of the EPI data that's being collected for fMRI now is being done on multi-channel receivers. And that was just not a part of what they were trying to look at back then.
Yeah, I think it's important to separate out, the quality of your scans, with the phantom, you can, and I think that's still important to do, because, you don't want all the variability of people. But at some point you want to assess what can go wrong with a person. You could have the shimming is a big source of potential noise. Subject moves, somehow, but usually for instance, the interaction of the TR and the TE, most patients are most subjects are, have the same, Wald effect and things like that. So that's not really something to worry about too much when you're doing, the standard QA. I mean, phantoms can cover almost everything. The only thing that they can't is necessarily the shimming with the subject. That might vary.
That what Sean said sounds like we really need to update FBurn.
But FBurn was very well funded at the time. I think that's those papers came out of a fairly large grant.
Well, I mean, we could write a grant if people are interested.
But
well, I mean, the problem with that, I mean, I really do. Yeah, I mean, it's a moving target to sort of, the technology keeps on changing, the coils change, the sequences that we use change, and all of those might have their own standards and metrics. It's tricky to actually capture
but
that.
SMS here, but SMS is here to stay, right?
Sure, but there might be different flavors. There might be, hybrid paths through K-space and different coil configurations. So, and it might be captured by this, but it's important to think about this really carefully in that regard. And it all depends on the goal. I mean, maybe I lost track of the goal. What's the goal? Is the goal to, if it's for data pooling, I think the only way to do that is to collect metrics with each subject. If it's for just making sure your scanner runs, then you could come up with a menu of various sequences that you could sort of hit the parameters. It really depends on what the goal is here.
Nick, go ahead.
Yeah, I'd like to echo what Peter said. I think complexity is, even if you just look at multiband, I don't know how many implementations of the image reconstruction are out there, and they all play with, effectively, all of us play with the trade-off accuracy and precision, right? Get more artifacts, get more systematic noise, get more random noise, and that can change the results quite massively, and also what you would be looking for in terms of quality control, and it gets even worse with, let's say, image reconstruction that includes strong priors and aspects like that, and for us, unfortunately, and I don't see that changing. The image recon remains a black box, the one provided by the vendors. So that really, if you want to get that all right, I think this is really a moving target, and you would need to invest probably a lot of time and effort to capture that all in a fair, useful way in the end. Because with every software upgrade, you might actually have a significant change. I mean, I guess in terms of maybe checking some of the hardware aspects that have now consistently changed, like having multiple received channels and having more, let's say, slightly more sensitive approaches for that, that sounds reasonable to me. And it sounds like some people do that. They use the board tools or have developed their own. Maybe also in terms of multiple received channels, one could think about it. But I think I probably wouldn't overdo it in terms of looking too much into the specifics, because then the risk is, I always find it most important, we talked about it at the beginning of the session, that you do the QA, I think is more important than doing it perfectly and capturing everything. So that would be my opinion on it. So maybe try to approach it by investing as little as possible and get the maximal benefit out of it.
Thank you. Any other final comments or questions? So we
really
advertised
quickly,
it until.
If I could just add really quickly, I'm sorry for interrupting. one idea is that you could even have a strange sort of QA where you just, push the parameters of, push the RF in some sense to check for RF performance, across different powers, or, push the gradients a little bit. And so you just sort of like, you come up with these, projections through this sort of space that sort of captures, every possible iteration you could do with the scanner, but very elemental in some sense. You wouldn't get like images, you might get some sort of parameters of that measure RF stability or, gradient performance or things like that. But and that could predict how things will go with the various iterations of pulse sequences and reconstruction.
I just wanted to quickly mention that I'll keep it going, but if somebody needs to go, please go ahead, no pressure. So I think because this is a good time we are really warmed up. So those who have the time, please stay on and ask questions and discuss. So for me, from my perspective, from the group, I feel like we should have a small subgroup / task force to, like what Peter said, think carefully about this, try refine the goals, and maybe ask a few questions that we could answer today that will be potentially useful for at least 10 years, because the goal is a little bit changing. But I think that the multi-band / SMS techniques are here to stay. And what we learned in the last 10-15 years can be used to improve system, both the facility QA as well as the human QA. So if we can kind of offer some good suggestions and maybe divide them by what is easy and simple that everybody can do, and what is the best one can possibly do if they really invest time and resources into it, So that is probably something, a couple of pages of recommendations we could probably come up with easily. What do you guys think?
Yeah, I mean, sure. I mean, you could do that. I mean, yeah, it's really, I think it should be done. It's something good to try to do, but yeah, I think it would have to be a sort of maybe a wider consortium that, yeah, it's hard because I think that everyone is trying to solve their own center's problem, and I don't know what I mean, you're really, once again, you have to look at the goal. I don't know what the extra added value necessarily will be in this regard. Like I said, I'm sort of in the camp of this scanners hopefully will work well, and it's important to make sure that they work pretty well, that they work above threshold. Sequences are going to be very different. Recons could be very different. But just collect, I mean, there's so many variables that then change when you put a subject in, and you want to make sure I feel that you want to make sure that those data are good. And so I'm really more along the lines of collecting as good metrics as possible from each time series with the subject in there, as opposed to sort of trying to capture this exploding multidimensional space of scanning with phantoms and sort of standard, and then standardizing it and making everyone do it. It's just a mess right now. My feeling. I mean, FBurn was done in a very much simpler time, and it was hard then. I think it would be nearly impossible to really take that on now, I think. And why not just do it after why not collect your metrics, with each subject time series, and because that's what, to me, that's what the goal is, to sort of have data that are good enough to put to report in papers or to put in repositories. And that sort of kind of captures that. That's my feeling. So,
Nick, go ahead.
Oh, I just wanted to tell you, so I have a subject with a low default mode network. So my challenge to you is to tell me, based on the time series of 300 dynamic time series, tell me if he's low because of scanner badness or is he low because of biologic badness?
Yeah, you can just measure, I mean, you could just do a temporal signal to noise, make a map of temporal signal to noise, maybe look at the low frequency fluctuation power, and you should be able to separate that pretty quickly with that regard.
Okay.
Nick?
Yeah, I think I'm kind of in two minds about it. We see Peter's points, and I would say I kind of largely follow them. That you need just go for a pragmatic approach. Make sure that the scanner works in principle and try to cover the most important bases. And as long as you do a QA, you probably do 90% of it. Now the question is always about these diminishing returns, right? You invest 50% more into your QA procedures to gain 5% knowledge, so to say. Is it worth it? It's a hard trade-off. I don't know. I mean, I don't have a strong feeling about it. It's probably, I would agree, to extend it into the kind of multi-channel receive domain would be nice. But I think there are 2 points I'd like to make. One is regarding the FBurn protocol. I think one of the strengths was that they also offered the entire package. They had the Phantom as well. So it was relatively easy. You just copied the whole thing. You bought the Phantom even from them, and you could implement it relatively straightforward. So I think that was a strength. And I think there's one more aspect is the question about, in principle, you also need to test whether the QA helps. And there we get into this domain. How do you do that in a sense? Do you say, I just count the number of studies that failed with over 10 years with this QA protocol versus another one? Do I look at just data quality, but then it becomes circular because I use the QA to look at data quality, and then it's a self-fulfilling prophecy. So what is our metric in the end for that it's a successful approach and that it's worth it? If you count, let's say, person hours spent on programming or scanner hours spent on running QA. So I mean, there needs to be, I'm sure that there has to be an optimum, so to say, and I'm not quite sure where that lies. So this comes to my mind when you ask, should we do it as a community? I'm sure if somebody did it, others would be happy to use it and take it, but the part is somebody has to do it and put the time and effort into it.
No, so
I think that's an excellent point about, how do you measure success? I think one way to measure success, though, in terms of facility QA would be that you can detect early things that actually turn out to be problems later. So, and that's a very obvious thing. Like if we have a measure, like watching the voltage will tell us maybe a month or two ahead of time that our gradient coil sprung a leak before the system actually throws a systematic error. So yeah, I think that's an excellent point, Nick, but that might be one metric. And that's kind of the things, at least in terms of being running a facility, that I'm looking for is like, how can I tell my scanners running and something might be going sideways before it actually hits the threshold of throwing an error or the manufacturer's
right. I can give another example, but maybe not the imaging data. For example, one of the issues we ran into was protocol compliance on the Siemens scanners. There's a very specific bug on how when you implement these sequence protocols, when text often copy paste parameters, and apparently in one of those steps it switches the PED, phase encoding direction, and it's been going on for some time. And nobody looked at it because everybody assumed everything is okay, So one of the things we're trying to implement is this daily protocol checklist, so to say, during the scanning itself to catch these errors. But it's a collaboration between the technologist and the RA doing this scan. So the reason we may not be able to answer your question with the data, Nick, is that because nobody really thought about it, in my opinion. Everybody assumed everything is okay, and if we dig more into it, I think we'll find it. Todd gave a good example of a byte data set. When they looked at it, they could maybe you can give the stats again. There was a lot of issues with scanner badness causing changes in the DMN. So is it worth it? I think so. When you were asking these questions, I think what I was thinking was we don't know what's a good minimum baseline QA to be done to catch that 90% you talked about. Is there clarity on it, right? I tried to reach out to Gary Glover, the first author for the F1 QA guidelines, and he is of the impression that they don't need to be updated. Whereas another expert on the same guidelines, Thomas Liu, thinks that there is a need and multi-band is one of the good reasons to update them, right? So this makes me think that there is no clarity on just do this catches 90% of the errors. There is no such thing. So this goes back to, like, it could be a best practice that OHPM BPC can do, Peter, to answer your question. This is the minimum, not the minimum. This is enough to catch most of the common or most of the known issues. I don't know if we know that today, especially given the context of most people use multi-coil, multi-band data, right? That's what I was referring to, and whether to harmonize it across different phantoms, I think that's a whole different ball game that may open up another research opportunity of how do we harmonize across phantoms, forget sites, right? Is that a problem or maybe not? I don't know. So that's something to be think about. Maybe I think it's probably an easy one to do because it's all phantoms, very well controlled known characteristics and whatnot, right? Yeah.
Yeah, I think one thing I'm taking from this discussion, and from what Peter said too, is that as we think about these things, is to think about the cost benefit analysis, right? I mean, we could spend forever trying to harmonize phantoms and dial everything, but in the end, we really just want good data for our users and researchers. And so highlighting and I think Pradeep, you're kind of getting that too, like what are the 90%, what are the big things to watch out for? And maybe we need to add in a couple new things. Like I would say doing a coil check and making sure that now that we're doing multiband and using phased array head coils to make sure the elements are good. That seems to be something that should kind of be part of the routine. But how far do we need to go beyond that? This discussion has kind of made me think twice about the effort versus a 5% benefit when your subject is still the major source of your noise. So.
Yeah. I just want to reemphasize what Nick mentioned as well. I mean, the recon is a big factor here. And it's making an increasingly bigger difference, and it's a black box with a lot of the vendors. And so, you could think, oh, there's a problem with the gradients, and it's actually a problem with the recon. So it's that has to be transparent, a little bit more transparent first, I think.
So any other burning comments or questions? What keeps you up at night? I guess that's the question I wanted to ask all the panelists. Maybe we can start with Peter. Regarding QA.
Yeah, no, I have nothing really. I mean, I guess the sense I have is that it's an increasingly, this whole problem is an increasingly moving target. It's moving, it's morphing faster and faster. And I think that people have to have, right. I think we need to have sort of, basic principles in which we can at least assess the hardware. We need to have open recon. And I think that having some basic things that we do to sort of predict a lot of things, 90%, whatever, is great. But then we really do, to progress, I think it really, really would help to have metrics that you collect with every time series. So.
Yeah, Robert?
Yeah, I think what Nick mentioned, I think it doesn't really keep me up at night, but it might be a burning question. in terms of how to optimize the effort and the outcome. I mean, now with the PDX, we don't actually do anything to check for the different transmit channels. So that is something we really have to think about. But on the other hand, if we would like to check for more or less everything, then yeah, we would have to do a 3 or 4 hour QA every day, and then that's not feasible. So where to draw the line is kind of the question for me.
Nick?
Yeah, as I said in the beginning, I always hope that the scanner will not keep me up at night. So I think, I mean, yeah, I think most has been mentioned already. Complexity simply increases, and on purpose. I mean, we all try to shift the hardware issues and try to make them software issues that are cheaper to solve, and all these kind of things. And it brings up the whole thing also about, you know, software quality assurance actually at the back end. And so, and that's for me, I think, I guess the point why I was kind of said, you know, one has to balance effort versus what you get out, because there are actually a lot of things we need to take care of in the neuroimaging lab, and it's not only the hardware quality, but it's actually the quality of the science, the quality of the programming, and so on. There are a lot of construction sites in a neuroimaging center, and so I was wondering, maybe it's rather a question, maybe if there's anybody at the moment out there who might have, you know, a large center study where you anyway need to take care of QA, and maybe one could piggyback on it. So they would really benefit from it. We could give input maybe as a group, but they kind of could do the work, so to say, right? I think I would be more than happy to give input, but I think in terms of depending on how much work and coding and so on goes into it, that's more critical. Maybe there's a chance there. And because we recently had a case, for example, that was more about anatomical imaging, and we addressed, for example, the issue you brought up that protocols aren't consistent. So there we developed a tool that reads in the DICOM headers and checks it against the standard. So it's just the first kind of line of check.
I need it.
And that was done for a clinical multi-center study, but because you need it there as an example.
Yeah. So I tried to reach out to the ABCD people, actually. I tried to get, and they have been very busy. I have not been successful yet, but maybe Peter knows of other studies that we could probably reach out to, and I don't know if other people know.
Yeah, I mean, right. I mean, I'd have to think about that, but I mean, the ABCD people are, yeah, they you know, there should be, you know, accessible. I mean, but yeah, you know, there's a lot of big groups, even UK Biobank people, and you know, there's they only use a few scanners though, so
yeah.
Yeah.
I mean, the ABCD is probably using most of the best guidelines, so to say, because they started late, and they have the good experts too, I think, on their committees to keep it going, but something to be revisited again. So thank you so much.
I was going to put in two things real quick. Sorry. About I'll jump into what keeps me up at night. One is potentially too quick adoption that's too fast, and the example I'll give with that is the banding artifact in the multiband acquisition. That was kind of, seemed like everyone was already doing multiband, and then we realized that we needed to have our excite pulse duration longer to try to mitigate this artifact. And what keeps me up is like doing that, have people scan a year of data and finding out that kind of artifact actually makes a difference in data quality. And then the second thing that I worry about are things that are very difficult for us to catch with phantoms, but make a big difference in practical scanning. And like main example of that, and like when I teach and when I advise researchers running my center, and this is a specific multiband / multi-channel coil acquisition thing, is moving during the reference scan. And that's something that some people talk about, but a lot of people don't talk about, and it's not something the manufacturer mentions that this happens and this is important. And so those are the kinds of things, and you wouldn't detect it with a phantom because motion during reference, phantom doesn't move during a reference scan. So those are the things that I kind of worry about in terms of finding out 6 months, year, 2 years later that data quality from users is bad because of kind of insidious bugs or insidious problems like that.
Thank you, John. It's wonderful. Anyway, so I guess there's a lot to talk about, so we'll have to come back to this with multiple sessions. Thank you again, Peter, Nick, Robert, and everybody else. Much appreciated. I'll send this video to the group and keep the discussion going. Thank you.
All right, thanks.